Good morning. Oh, you're already doing research.
Yes, that's right. I want to win the Ig Nobel Prize this year.
Why don't you aim for the Nobel Prize anyway?
What? Did you say something?
Forget that, tell me what you said yesterday. I thought you said you hadn't invented zero yet.
Oh, that's right. Well, let's get started. It's been over 500 years since the discovery of negative numbers.
That's epic again.
I'm sure you've heard of the discovery of zero.
I may have. Are you saying that you came here by any chance?
Yes. This feat was achieved, of course, in India, the country of mathematics. India produced the famous Ramanujan, and is a mathematical powerhouse that can remember multiplication to 2 digits. Even today, India leads the world in IT technology. It is said that India established the concept of zero in the 5th century.
It is indeed the land of curry. I'm sure Gandhi would be pleased.
That's just a list of words you know in India. The invention of the zero is very significant because it introduces the concept of digits. Roman numerals are very hard to read because they don't have digits like this.
What's this?
These are the Roman numerals engraved on the dome of the Massachusetts Institute of Technology. It is said that one of the reasons why zero was born in India, not in the West, is that in the West, Aristotle's statement that nature abhors a vacuum gave rise to a cosmology that denied the existence of nothingness, while in India, Buddhism had the concept that, what is not there is there.
I don't know what you're talking about.
It's okay. I don't understand it either. And from here, it'll be another 1,000 years.
I'm going to be nothing.
Well, 1,000 years have passed. We've arrived in Italy.
Wow, the canal is beautiful.
The year is 1545, the middle of the 16th century. Guess what's next?
Natural numbers, fractions, irrational numbers, negative numbers, and zero were born, right? Then decimals were next.
Boo. The correct answer is imaginary numbers.
Seriously, imaginary numbers are the last option. I can't believe it's faster than decimals.
It was a man named Cardano who discovered the imaginary number. He was the one who published the formula for the solution of cubic equations, and while thinking about it, he came across imaginary numbers. Would you like to solve this equation?
Oh, you can write a decent equation now, can't you?
I'm going to improve my skills little by little.
Yeah. The answer is 1?
Correct. In the range of real numbers, yes. But if you use imaginary numbers, there is a better answer. That's what this is.
It means that there were 2 other solutions that contained imaginary numbers.
That's right. By the way, look at the real and imaginary parts.
Well, it's the ratio of the lengths of the sides of a right triangle.
How did you notice that? Well, this is a long story, so let's talk about it another time.
Oh, no, I have to wait again.
Since imaginary numbers appear even in such a simple equation, the formula for the solution is very difficult. Do you remember the case of quadratic equations?
I've seen it before.
For cubic equations, it's like this.
That's too hard.
But he only published the formula for solving cubic equations that someone else had invented.
Cardano, that's not fair.
I heard he got into quite a bit of trouble for this. But as you can imagine, imaginary numbers were not immediately accepted. Imaginary numbers were seen as meaningless, and for the next 100 years, they were rarely used in mathematics.
I know, right? Imaginary numbers are meaningless. It's as meaningless as the Diet Coke that comes with this lunchbox.
Why don't they just drink a regular cola after all this? But the imaginary numbers do have meaning.
What does that mean?
By thinking about imaginary numbers, you can think about rotations on coordinates. And in physics, it's used in the Schrödinger equation, and the calculation of AC power. So, although it's a number that doesn't exist in reality, it's a really interesting number that can be used to think about real things.
Wow, that's strange.
But when you think about it, isn't it the same with negative numbers? At least if you taught negative numbers to people in the past, they would say, "What's the use of such numbers?" I don't get it, right? That's what mathematics is all about, isn't it? By the way, I said earlier that it was not used for over 100 years, but it is said that it was Euler's formula that brought imaginary numbers back into the spotlight after its discovery. It's said to be the most beautiful equation in the history of mathematics. I'd like to make a video about this sometime. It's really beautiful to see the imaginary numbers in this. Next, we'll arrive at a World Heritage Site.
Oh, you mean the Grand Place in Brussels, Belgium, right?
That's right. Well, the decimals are finally coming.
I'm so happy. What kind of feeling is this?
Actually, decimals were created quite recently. It was the late 16th century, or almost the 17th century. Of course, it's not that they didn't deal with numbers less than 1. Fractions existed, and they were written in units of 1/10 or so. However, this was the first time that modern decimals were used.
Well, you can certainly substitute fractions.
I'll spoil it for you, but it's almost the same time as the logarithm was announced.
That's also surprising.
Moreover, there is only about a 10-year difference between the time logarithms and decimals were invented. We've been flying for hundreds of years as a matter of course, but 10 years is really not that far off from being simultaneous, right?
I wonder why?
There is a reason for this. The people who were active in this era were Kepler, Galileo Galilei, and so on. You've heard of them, right?
Oh, the guys from space and stuff.
Yes, astronomy was flourishing. This coincided with the development of telescopes, and decimals and logarithms were born out of the development of astronomy. It is said that decimals were first presented by Simon Stevin in his book The Art of Tenths, published in 1585. It is said that Napier started calculating logarithmic tables in 1594, which is a difference of 9 years. Let's move forward in time a little.
Wow! It's a nice, quaint view.
This is Scotland. You can see an old castle in the back.
I can feel the history.
Now, let's talk about logarithms. Napier officially published his logarithm table in 1614, so some people think logarithm is early 17th century.
Wow! It's written all over the place.
It took Napier 20 years to make this logarithmic table.
Wow, that's a lot of work.
But that's how meaningful it was. He even named it logarithm.
What does that mean?
This name is a combination of logos, which means the word of God, and arithmos, which means number.
That's quite a grand name.
He said that the discovery of logarithm was a miraculous gift from God. Many people thought that calculating logarithms was a pain in the ass, but for astronomers and other people who deal with large numbers, logarithms were really useful. A great scientist named Laplace even praised logarithms, saying that the logarithms doubled the lifespan of astronomers. The universe, something so huge, is now ours to handle. With God's tools.
That's pretty cool.
By the way, Napier is famous for discovering logarithms, and his name remains as Napier's constant, but he also made great achievements in decimals.
There's a guy who can do it all. You know, the ones who can play football and get good grades.
And to top it off, he was a castle owner and a nobleman.
Oh, so he could play football, had good grades, and was rich. That's Superman.
Anyway, Stephen's decimals were written in a rather annoying way.
What's this?
That gives us 19.178. It's easier to use the decimal point that Mike always uses, right? This decimal point is said to have been invented by Napier.
Thanks a lot, Napier.
Now that you've seen it all, what did you think?
Well, fractions fast, imaginary numbers too fast, decimals too slow. Also, the numbers that we take for granted are starting to look very grateful.
That's good to know. Now you understand what Kronecker meant when he said that humans invented all the numbers except the natural numbers. All numbers were developed because we need them, and modern society wouldn't be possible without them. I think it's time for numbers to start looking cute.
Speaking of cute. I forgot I was supposed to meet Jesse. See ya.
The ending is the same as the first episode. In this channel, we will continue to post videos on topics that make science accessible and fun.
If you find today's video interesting or informative, please click the good button and subscribe.
Also, please feel free to comment or question.
See you in about 30 years. Bye.